Here is our last example. This example is going to be done twice in two different ways, and it's really much more complicated than all the problems we did before. Water is pumped into inverted cone with a radius of 6 feet and height of 8 feet at the rate of 2 cubic feet per hour. How fast is the water level rising when the radius of the water level is 3 feet? Please read it again. We have to understand the situation. There is a container and water is pumped into this container in a given rate, and we have to find how fast is the level rising, because obviously if you pump water into a container, then the water level is rising. As usual, we will start with the always true, and let's draw a label and see what is given, which is always true. First, here is our container. The container is an inverted cone, and when we fill water in, we have a small cone in this cone because the water is filling in, so the shape of the water is of the shape of the container, which is a cone. Here's the level of the water. We are going to denote this and label this by little r. This is the radius of the container, which is given to be 6 feet. The little r depends on time, but obviously the container stays the same, so the radius of the container is always 6 feet. The height of the container is always 8 feet. But the water level is rising and changes all the time, so we have to label this by h. As you can see, r and h are functions of t. What is given that is always true? It's only that the water is pumped in the rate of 2 cubic feet per hour. It means that this is the rate of the volume dV dt is 2 cubic feet per hour. The main equation is obviously the equation of the volume of a cone because we have R, H, and V. The volume of a cone is 1/3 of pi r to the power of 2 times H. To avoid using the product rule, we may eliminate one variable. As I told you, I'm going to do this problem twice. Now I'm going to do it with eliminating one of the variables. I'm going to redo the problem without elimination of the variable. For this, I'm going and I'm taking the middle cross-section of the container. This is this. Let's see. You can see that there are two triangles here which are similar. So I really can get some connection between R and H because I have the 6 feet and the 8 feet from the bigger triangle. For example, this is a good ratio to take. R over 6 equals H over 8. From here I can solve for R and I can also solve for H. The question is, which variable do you like to eliminate? As you can see, I'm going to eliminate the R. The reason is because it's r to the power of 2. So R equals 6H over 8, which is 3H over 4. Here's the main equation. I'm going now to substitute 3H over 4 instead of the R, and I'm getting that. Now we really like to simplify the equation before we do everything else. So we do that, and then we can cancel the 3. And that's it. You cannot simplify this anymore. And we get that the volume is 3 pi over 16 times h to the power of 3. So here's the main equation. Now we are going to differentiate, and we get dv dt equals 3 pi over 16 times 3h to the power of 2 dh dt. Again, we simplify some algebra here, and we get that. We are done with the always true. Now we have to focus on the snapshot. Let's see what do we need for the snapshot. First of all, we know that dv dt is 2, because it says so. The water pumped in at a rate of 2 cubic feet. We also wrote it, by the way, before, and we know the dv dt is 2 cubic feet per hour. The question is about the water level. Supposed to be 3, but if you can see in my equation here, I have to substitute h, not r. It looks like a big deal. So when I get to this problem, I need to solve it. So I'm going to find h when r equals 3. I would like to recall the similar triangles. This is always true. You remember that this is always true? Well, so now I'm substituting r equals 3. And you can figure out immediately that h equals 4. You can use this ratio, or it's enough to see that 3 is half of the 6 feet, and h has to be half of the 8 feet. So whenever you like, just do it right, and you will get that h is 4 feet. Well, now I can go ahead and I can substitute this. Now everything is clear, and I can find dh dt. I like it because they ask me about the water level, and I'm going to solve directly for dh dt, which is the water level. So let's solve. Okay, we can cancel 16, which is 4 to the power of 2. And we get dh dt is 2 over 9 pi feet per hour. So we can answer the question now. When the radius of the water level is 3 feet, the level water is rising at a rate of 2 over 9 pi feet per hour. My experience showed that many people don't really see that it is easier to eliminate a variable. So I would like to redo the problem, but now we are not going to eliminate the variable. We are not going to start from the beginning, because we already know what is always true. It is the same picture, obviously, and also it's the same main equation. But now we are going to differentiate very differently. We notice that r and h are both functions of t. So if we want to differentiate r to the power of 2 times h, we have to use the product rule. And here is what we get. Pi over 3 is just a constant, then we have to differentiate the first one, which is r to the power of 2, and we get 2r dr dt times the second one, which is h, plus now we have to differentiate the second one, and we get dh dt times the first one, which is r to the power of 2. As you can see, now we will have to substitute r, h, dh dt, and dr dt. And obviously dv dt, but we know that this is 2. We are now going to focus our attention only to the snapshot. So let's see. We know that dv dt equals 2 cubic feet per hour. We know also that r is 3 feet, and the reason is because they asked me to find dh dt when r equals 3 feet. But I still don't have h, but I can find h. We did it before, I'm going to do it fast. Again, you're using similar triangles, and you get that h is 4 feet. Now I also have this guy. I substitute the numbers and I want to simplify before I will continue. I can cancel 3 here and here because this is over 3 and this is times 3 to the power of 2 and 3. I get this. Now I have one big problem. I need to find dr dt. There's no way really directly to find it, but to find it I'm actually doing a small related rate problem that is within this much larger related rate problem. Because of similar triangles, I can actually to find dr dt as a function of dh dt because r is a function of h. We know that r is 3h over 4. It means that dr dt is 3 over 4 dh dt. And when we substitute this, you get only one variable, which is dh dt. And now we have to solve for dh dt. First we simplify the algebra and you get easily the dv dt equals pi times 9 dh dt. It means that dh dt is 2 over 2 pi feet per hour. And obviously we got the same answer as before.